We are now going to answer this example before us. It says that we need to plot the data in the table below. So here's our table. We have speed and we have stopping distance. Let's first determine what our explanatory and what our response variable is going to be. So the speed is going to be my explanatory variable and the stopping distance is going to be my response variable. And it's because if we think through this logically, if you're going really, really fast, so you've got a high speed and then you slam on the brakes, it's going to take you a long time to stop. When if you're going very, very slow and then you slam on the brakes, you're going to stop very quickly. So the speed explains the stopping distance. So that's why it's the explanatory variable. Okay, let's plot this so we can see what it looks like. So we're going to come to our trusty CAS calculator, and I've actually already done it for us. So I've gone into spreadsheets, I've called this speed, I've called this stopping, and I've filled them in. You might like to pause the video and do likewise. Having done that, you're then going to go Control, add doc, add data and statistics. Then you're going to come here, and because it's your explanatory variable or your x-axis here, you're going to come here and you're going to put that as speed. Then you're going to come to your response variable, your y-axis, and you're going to find stopping, which is, if I can get there, I've got to delete all these things. There it is, stopping. And as you can see, it's got a bit of a curve to it, doesn't it? It's not that linear. So what can we do to help this problem? Well, we're told here, use the x squared transformation to linearize the data. So x squared, well, remember, your explanatory variable is x and your response variable is y. So when it's saying x squared, it's saying we want to take all the speed and we want to square it. And by doing that, we should transform our data to become more linear. And that makes sense when we look at the graph, because we know that when you square bigger numbers, it has more of a stretching on them. And if we were to take these big numbers here, these big x values, and we were to square them, it's going to push them further out, which means it's going to become more linear. Perfect. Okay, so let's do that. We have to jump over here, and we're going to call this one over here the speed, but SQ, because we're going to square speed. And again, we're squaring it because it's my x, it's my explanatory variable. Then we jump to this cell here, and you hit equals, and then I want you to hit var for variable, and I want you to find speed, and then hit this button here. You're going to square it, and then hit enter, and then it populates it for you. We have squared all the values in this column here. So all of these columns have been squared. They're now over here. Now we can jump back over here, and I want you to see what happens when we change this to speed squared. It's going to become more linear. So brace yourself. You're about to see something amazing. Ready? Are you blown away? It is now more linear. And that's because we've applied this transformation to it. Amazing. All right, let's jump over here. What do we have to do next? This says fit a line to the transformed data with y as the response variable and x squared as the explanatory variable. Then let's just zoom out here a bit. It says write its equation correct to two significant figures in terms of the variables. So what we need to do now is find our least squared regression line. And there's two ways to do this. The first way is to simply go menu, analyze, regression, and then go show linear a plus bx. And right there is our least squared regression line. So what we have to do is make sure that we round it to two significant figures. And also, because it says in terms of the variables, we're not going to say x and y. We're going to say speed and stopping distance. So let's write this down. We're going to come here, and I'm going to say stopping distance, because that's my response variable, is equal to, now it's negative 0.095, that is two significant figures, plus 0.015 times the speed. Now this is the bit that everyone forgets. You have to square it, people. Please burn that into your brain. Because we've applied the x squared transformation, you now have to square your explanatory variable. So make sure you do that. And there is our answer. Perfect. Now there is another way of doing it. The other way of doing it is jumping over here and going menu, statistics, stat calculations, linear regression, and then for our x, we want it to be speed squared, and for our y, we want it to be, if I can come down to the bottom, stopping, and then hit OK. And you see how my a value is negative 0.95, which is what we saw before, and the b value is 0.01469, which is also what we saw before. So that's another way to do it. Perfect. Hopefully you got that correct, and hopefully you were able to round correctly to two significant figures. Let's now move on to the next part of this question, which says use this equation to predict the stopping distance correct to two significant figures when the speed is 100 kilometers an hour. So what we're going to do here is we're going to take our least squared regression line again, set it equal to negative 0.095 plus 0.015 times. Now, instead of speed, I'm going to put in the speed they've given me. And just to make this nice and clear, I'll do it in a different color. So I'm taking this and I'm putting it in there. But you have to remember to square it, people. You have to square it, okay? Because that's what we're doing. Our least squared regression equation has a square there, so you have to square it. That's what people forget. Okay, then you're simply going to put this into your calculator now. So if we come here, and let me just come to our calculator page, and I'm going to go 0.095 plus 0.015 times by 100 squared. And let's just double check that I've done that correctly. That looks good to me. And I'm going to get that 149.905. Let's write that in. 149.905. Now it says to two significant figures. You might like to pause the video and see if you can figure out what two significant figures of that is going to be. It is going to be 150, where 1 and 5 are your significant figures. And we are done, everyone. That is our answer. So hopefully you found this helpful and you feel comfortable with using your CAS calculator to perform an x-squared transformation.